from the perspective of power generation, I think it's very interesting, a very interesting phase that we are in Germany, and also STEAG is in, and a large part of that maybe can be transferred to Southeast Asia and other regions, and I think also to Indonesia especially. So if we look onto STEAG, and I don't want to bore you with many figures from STEAG, something I think everybody can read. I want to point you to one of the figures here on the right side. Is we are currently operating roughly 7,500 megawatt in capacity, 7,200, and thereof we operate 5,000 in Germany. And that figure is the important one to look at, because that is going to change. That is going to change because of the change of the transition of the energy market, of course, in the global trend of decarbonization, but also in terms of the political trend we are currently facing. Because you maybe have known that we are exiting the coal, and a new government is just getting in place. It's not yet fully designed, so it will be getting in place in the next weeks. And this coal exit that is driven by a law since 2019 will most probably accelerate. And that means these 5,000 megawatt in Germany will face fully a dramatic change in the next years to come. So that means a part of that will be decommissioned, part of that will be transferred into other sources. And now, if we come to the next slide, we see, which is interesting, what drives the strategy, in this case, the STEAG strategy, but I think it's a lot of that is relevant for many power generation companies. So of course, politics is driving that. Politics is driving a lot of that change in Germany and in Europe. And a lot of that has driven our change. It's, I'm just going to mention a few of those. It's been the nuclear exit in Germany, which is also right ahead of us. The last nuclear power plants will go from the grid, will be decommissioned end of next year. So, and now the coal exit will be there until, most probably until 2030. So that means in roughly not even 10 years from now. So, and of course, other things that change now, I'm going to the right side of this slide, is the prices, the electricity, which is driven by the coal and gas price, but also more and more driven by carbon dioxide prices, if you look to the conventional power plants. And that means, and the market is dramatically changing from rather large plants to more flexible and short plants. That means there is a change in the technology that's going alongside the political change and the market change. And that change is going to, of course, renewable. That trend is already there for 20, 25 years. That change is going to other changes that are now transferring, and that will accelerate now with the decarbonization of the industry. And if we go to the next slide, we see this triangle that we are working in. In a very general term, we have a triangle that we are working in as a power generation company within the decentralization. Just I think describe that decentral trend from larger power plants, plannable operation, to smaller plants, renewable plants, battery storages, and other topics. And that all is driven by the decarbonization trend. And that overall trend that is now accelerated by politics forces the development, or even accelerates the development to again the decentralization, because decentral smaller power plants have, of course, another life cycle. They can be quicker in the market. And the other trend that we see and that we face already is digitalization. And why is that? Digitalization playing an important role here. The rather decentral market with a lot of players, consumers, but also generators in the market, generators of electricity now mostly, that will need to be managed. That will need to be managed in terms of grid stabilization, that will be managed in terms of consumption of electricity, and their digitalization is, let's say, inevitable even. So without a more automated and digital world, we most probably won't be able to be successful in this trend. So now just one slide that shows this decarbonization trend and the emission targets that we have. Is that you see a large from 1990, that's always the basis if we talk about also globally, if we talk about CO2 equivalents. And now where do we want to be in the next nine years, so until 2030. And that is very important to understand, that this trend, now driven also by politics and laws in Germany, and probably that will happen in many other countries as well, and is happening currently, and that discussion will certainly increase, a trend that forces us to change, and to change even quicker, I think, than we anticipated. And if we look onto the element of digital now on the next slide, it's the trend that it's not only the digital processes that are required to run plants in a more decentral manner, to quickly ramp up some capacity that's there, but also the business models. If you look onto the top part here, the business models of companies change, and the business model of our company changes rather towards a more digital business model. That means our digital products, that the automation, the monitoring systems that we have in Steag of plants will be more and more important to operate power generation plants. And that is, I think, something very important to understand. Besides another digital trend that is there in the market. So even the electricity trading is quickly moving to topics like green PPAs. So that means balance sheet driven purchase and sale of power from green energy or decarbonized energy. And also now blockchain models, like we also all know, the crypto topic will play an important role. If we talk about a high number of small plants that are decentrally located, we can imagine that there is not only one trading scheme and one big trading floor that trades the electricity. There will be many, many players in the market. Also, that is a trend that drives digitization. Now, how will this future look like? And I think I mentioned that a little bit here. Here it becomes quite visible on this next slide. It's a completely changed ecosystem that went from rather large, bigger plants that in Germany these were, but that's also true for Indonesia, for example. These were larger power plants, coal-driven, a few hundred, even to 1,000 megawatt. In Germany also, of course, nuclear played a role. High voltage transmission lines, then distribution into communities, and then to end clients, to households like ours. And how will this ecosystem look like? And we have just seen in Waqas, so that's why I thought Waqas' presentation was very interesting. We have seen that also now the mobility will be integrated in this sector of distribution, at least. Of course, that will end up also in the generation. But we have many, many more players, and you see kind of an ecosystem on this right side. All these players in the market now need to be connected. That means a few power plants, then there is many consumers. Mobility will play a much more important role in the future. Then we have a lot of renewable capacity in the market. In Germany, currently, roughly 40% of the capacity, of the installed capacity, is renewable already. So you can imagine if you work on that and the sun shines or not, or the wind blows or not, you need to work a lot on on the grid stability. So you go to the bottom part here, then you see that grid stability will be a very important aspect in the future grid that we need to manage. So we need to manage this ecosystem in the future, and there will be many more players in the future than there used to be. So now what does this mean for our coal fleet? Now I'm jumping back to an example of a large power plant. So what is the larger power plants that were originally, and I think that's similar in Indonesia, that were originally planned to generate in a stable manner a high capacity of power in a very plannable and foreseeable environment. So now you can see that that has already changed dramatically, and this change will, as explained, continue. So what did that mean for our power plants? So our coal-fired power plants mostly, but also gas-fired power plants, were forced to change, to adjust to the environment, because of course you cannot just decommission and then start something new. It's a transition period we're in. So first of all, the renewable power that is in the grid now, that will rise in its capacity. Let's just look onto the sun and the wind. The sun is there during the day, not in the night. The wind is there when the wind blows, and that is also not a very reliable source. However, it is in the grid, and you need to now to cope with the changes in this grid. And we have changed our power plants already to be much more flexible to respond to these changes in the grid. So that means that you don't start these power plants, run them, operate them. You need to make them much more flexible. Flexible means you need to ramp them up and down according to the load in the grid. And we have transferred this example now to the Indonesian case. And if we look onto Indonesia, roughly 50% is coal-fired capacity. And we already see that there are some cases in the grid where the grid gets unstable. Now we have made a study on a coal-fired power plant to run that in a much more flexible manner to cope with the changes that come into the market. Also in Indonesia, we see this trend. We have seen the new RUPTL that's there that focuses very, very much on renewable sources. And here in Indonesia, of course, it's hydro, solar, and wind mostly, and to some extent geothermal.
Next 5 minutes.
Yeah. That's fine. So perfectly there. So the next slide shows an example how we can now, if a bigger power plant is now flexible, what else can be done to stabilize the grid? Because it's in the end, it's a question of grid stability that you want to achieve. And a big role, large battery systems can and will in the future more and more play a bigger role. And we have installed large battery systems that are directly connected to the grid and that can respond to frequency changes within milliseconds. So that means all the changes of load and capacity that are in the grid can now be responded in a very short term by battery systems. So that other plants that are slower, and this is true for of course, renewable plants as well as coal or gas-fired power plants that are slower to respond, so that you can bridge this response. So again, another element that shows the future complexity. And these battery systems, by the way, will increase. Also, the grid operators will install more of these large-scale battery systems. And we have one in place that's operating for a few years very successfully. Another trend that I just want to mention, and then I will come to an end, is the trend of the industry that changes. And we have, and that trend is also driven by hydrogen. Hydrogen, not for the sake of itself, but hydrogen is playing a role in the chemical industry, but also in the power industry, because green hydrogen will be generated by power. So again, another player that is needed in the future to operate. And hydrogen will play a role in the chemical industry if you think about methane, methanol, but also of ammoniac. So in these cases, if you look onto synthetic fuels, hydrogen will play an important role. And we have just started a few own projects for hydrogen generation, for example, for the steel industry, but also a few external client projects where we have a carbon capture in place, capture the carbon, the CO2, and produce methanol with hydrogen. So that is another sector that is currently under development and that will play an important role. So again, a small snapshot onto the complexity that the market we are in, and I thank you very much.